All right, boys and girls, here we are doing investigation 3, activity 2. You probably got some instructions from Ms. Jacobs or myself on what to do, so we're going to do that now. So the title of this activity is, does 5 plus 5 always equal 10? So basically, what this is about is we're trying to figure out if liquids abide by the continuous model of matter or by the particle model of matter. And one way to do that is by using different types of liquids. So we're going to be using water and ethanol. And we have some measurements here, and we're going to mix some of these liquids together, and then we will come up with the result. And then based off the data, you will be able to determine if this is particle model or continuous model. So the first one is we're going to take 50 milliliters of water and 50 milliliters of water, and we're going to put them in a graduated cylinder, mix them, and then we'll see what we get. So we have two graduated cylinders here, both have water, and they both have 50 mils. You guys are going to have to take my word on that. So I'm going to pour them into this graduated cylinder. And while I'm doing this, you will see on your paper that there's something about the calculated volume. So you can go ahead and fill that out right now. You should be able to figure out what the calculated volume is going to be. And I put these two together.
And he is shaking them and mixing them up together as you are solving the calculated volume. So you have those values. So again, with those values, you should calculate how much we should actually see in the end. So go ahead and do that now while Mr. Gilbert is mixing up, again, water and water, 50 milliliters of each, and we're gonna see how much observed is actually comes out.
So I just mixed these up. I didn't want to make a mess, so I did it over the sink. So I'm going to get something from behind it. Ms. Jacobs, can you read that value so they can see?
Using the meniscus, we see that, again, meniscus is the lowest part of that bubble. That is exactly 100 milliliters.
Okay, so for the observed value, Ms. Jacobs is going to tell you what you need to put in there.
Okay, so we had 100 milliliters for that.
Okay, guys, so we just finished up part 1, so now we're going to do part 2. So what we have on part 2 is we're going to take 50 mils of ethanol in one cylinder and 50 mils of ethanol in another cylinder that we have right here. And then these are already measured out, so they're both at 50. And then we're going to pour them into this other graduated cylinder. I will mix them, and then we will take a look at what the value is. And I'm going to take these over to the sink and mix them up.
All right, while Mr. Gilbert is fixing those and making sure he mixed them up, so he's going to cap them and he's going to shake them up to make sure they're mixed properly. What you guys need to do is you need to solve for the calculated amount of volume. So again, we had 50 milliliters of cylinder 1, 50 milliliters in cylinder 2, and you need to tell me how much should be calculated if we add those two together. All right, seems like Mr. Gilbert's done, so let's go ahead and take a look. Ooh, that is exactly 100 milliliters. Take a look at that, guys. All right, so our observed is 100 milliliters. All right, so go ahead and write that down. For part 3, that is what we are on now.
So for part 3, we're going to now take ethanol and water, and we are going to mix these together. So this one is different than the other two. The other two, part 1 and part 2, you guys were using the same material or the same liquid, same type of matter. Now we're dealing with something a little bit different where we have 50 mils of ethanol and 50 mils of water. So I'm going to pour these into a graduated cylinder, and then I will take these over to the sink and mix them up so we don't spill.
Look at that as it's mixing. Kind of cool, huh? All right, Mr. Gilbert's gonna go ahead and shake that. As he does, again, your turn. Solve for the calculated. 50 milliliters of water, 50 milliliters of ethanol. What should our calculated volume be? Go ahead and fill that out now. Mr. Gilbert is done. Let's go ahead and take a look. All right, that is definitely under 100. I am seeing 96 milliliters. What about you, Mr. Gilbert? 96. All right.
96 looks good to me.
So, our observed is 96 milliliters. How is that possible? Hopefully, after you guys go on and answer questions 3 through 7 and go on to the simulation after that, we should be able to answer how is that possible.